Hi, so we're going to talk today about the chemistry of death, forensic stoichiometry, which is about chemistry, but we're going to make it more interesting talking about death. Here's the periodic table, but you notice there's several things here. There's lead on the left that looks like carbon, and there's arsenic on the right that looks a little bit like phosphorus or nitrogen. So both of those can replace things in the body in bad ways. Now, if you come to a body, you want to observe the scene, find the body, and then take the body in for analysis, and then come up with your conclusions. Used to be you did a lot of fingerprint stuff. Now you do DNA stuff because fingerprint stuff is not as reliable as DNA. You can search for blood stuff with luminol, but you want to be aware that that also can be triggered by feces, bleach, or horseradish. So in order to avoid having somebody mess with your blood, you can actually check inside the eye. Potassium, magnesium, other levels actually will give you a pretty accurate measure of when the person died. And if you're thinking maybe this person died of trauma, turns out your cortisol levels, the levels of adrenaline hormone in your brain, will actually tell you if that person died in trauma or just in their sleep. If they do have drugs in their system, there is a level of lethality. And if you notice up in the top right there, I've circled heroin. And then there's also nicotine is up there as well, morphine. Fentanyl, of course, would be off the charts, 100 times more potent than heroin. A number of other drugs on there not as toxic or as lethal. So they could be in the body, but not be the cause of death. Arsenic used to be the poison of choice. So basically, you'd kill people off with it because it was odorless, and colorless. But today we have many ways of testing for arsenic, so it's not a poisoner's choice anymore. Here's cyanide used in World War II. Pretty potent, very fast acting, going to kill somebody very quickly. What it does is it binds irretrievably to your oxygen receptors in your body. And once it's bound, you don't get any more oxygen and you die. Thallium would be your poison of choice today because it is slower acting and it tends to replace phosphorus and potassium in the body. So it'll kill somebody slowly, make them sick over time. There is a case of a person who was a chemist who got a hold of thallium. The difficulty is getting a hold of enough thallium to poison somebody over time. And this person poisoned them, but then was discovered because she was a chemist and they knew that she had access to thallium. So they actually checked for it. You can antidote it with Prussian blue. And Prussian blue is a dye that's very common, so that's a really good thing to know. Tetrodotoxin is a very, very potent toxin. Can kill up to 10 people, one frog. It actually binds to your sodium channels. So your body goes by sodium potassium channels. It'll bind them. They're closed. These are being bound open. And the other stuff, if you use a pufferfish, it actually binds them closed. So in one case, you're locked in tetanus. In the other ones, you can't breathe. So antidotes to each other, but both very potent toxins. If you didn't know foxgloves could kill you, they have digoxin in them. If you have foxgloves on your fingers, you can actually inhale it or take it in your mouth, not washing your hands, and it can kill you. This lovely fellow on the right, Charles Cullen, was actually very likely the guy who killed the most people in the world. He used digoxin, which is for the heart, and insulin and epinephrine to kill them. So people didn't know for a long time. We don't know how many people he killed. 18 consecutive life sentences. Here's some more popular ways to kill yourself. Alcohol, of course. There was a case of a hostess, those are hostesses there, who drank 18 glasses of hard liquor. She got paid, I think, $50 a glass. So she killed herself with liquor. And that's because it builds up faster in a smaller person than in a larger person, also very dependent on your liver function. You can also do this with coffee, takes a bit more, but you could also do it with Monsters. You could just drink enough Monster to literally kill yourself. So please don't. And here's death by antifreeze. You can actually kill a bear with antifreeze. It tastes sweet to them, and they just keep drinking it until they die. It basically builds up in your liver, very much like alcohol, turns into formaldehyde, which is a preserving agent, and off you go. You probably get rapid breathing and ability to urinate, convulsions, and then lose consciousness into a coma and then die. Here's an assassination weapon. This is ricin. Now, ricin actually binds within the cell and it goes inside the cell and it activates all of the cellular mechanisms. All those organelles inside the cell are activated by ricin and it kills you slowly, very much like radiation. And here's an assassination that actually was done by ricin. This is sarin, which is a poison nerve gas. It's been used in Syria most recently. Horrible war crime. And Botox, which of course paralyzes your muscles. People do it for cosmetic purposes. It's also found in honey. Don't give it to little kids, honey, because it can have it can have botulism in it. Death by ibuprofen. Advil, Motrin can be very toxic to your liver in large doses, also can kill you. And also lead. It can bind in your body, lock out carbon, and kill you. Try to avoid